Welcome everybody. Thanks to all of you for giving up a wonderful summer Saturday afternoon to come and listen to a presentation and get involved in a discussion about a topic which personally I feel is actually very important. Maybe even more important than getting a spot of sunshine or getting involved in any of the other multiple activities happening in London today. London Futurists is all about studying trends, forces that might become more important, might grow in significance. And London Futurists is particularly about looking at possible intersections between different trends, when one future, as it were, might collide and might be changed and transformed by another future. And today we're going to look at the intersection of two potentially very powerful trends. One trend is the trend towards greater artificial intelligence, machine learning, which is able to draw insight and information from huge amounts of data. There's lots of discussion about how quickly artificial intelligence might improve. There's lots of discussion about the potential drawbacks of artificial intelligence systems feeding information about us to governments or to corporations who then can use that information sometimes against our own best wishes. So that's the first trend, the growth and the power and sophistication and reach of artificial intelligence. But the second trend is concerned with sustainability of human life on this planet. As we are living in more profligate ways, consuming more resources, using more energy, growing in number, we are increasingly depleting the Earth's resources, potentially destroying our environment in ways that's difficult to be sure to quantify, but in ways that rightly cause a lot of concern. So the question is, how does the potential growth of artificial intelligence intersect with the potential growth of greater unsustainable living, or better put, a movement for wiser, smarter use of our resources? So can artificial intelligence in fact help to transform our use of the Earth's resources so that we live in a way that's much more beneficial rather than a way that for now might be a lot of fun, but in the short term we might regret. So to talk us through all these issues, we're very fortunate to have with us Alex Housley, who is the founder and CEO of an artificial intelligence company called Seldon. He'll talk a little bit about that. His background includes a spell at City University, where amongst other things he already had one startup under his belt, which he might talk about as well. But more recently he is one of London's leading lights in thinking big thoughts and challenging thoughts about how we can use artificial intelligence in a way that really does benefit the planet and not just benefit one or two corporations looking for a way to make more profit. So let's welcome to the stage Alex Housley.
Good. Okay, well, thank you. I echo David's intro, and really thank you all very much for giving up your Saturday or a bit of your Saturday afternoon to come and hear me speak. I usually have other people speaking at events, so if I mess this up, then I haven't got other people to kind of back me up. But I want to start by just really sharing a little bit about my experience over the last sort of 15 years or so. And talk a little bit about how what is AI, what is machine learning, and how that intersects with sustainability as a potential sort of device that we can use to tackle some of these huge global issues. So to kick off my journey into AI, so I actually started my first startup when I was at university back in 2003. It was called Total Hotspots. So it's a Wi-Fi hotspot locator service. So around that time, laptops were only just starting to have kind of Wi-Fi chipsets embedded. And basically what I ended up creating is a data business which helped people to find access while they were on the move. Because obviously around that time we couldn't use our smartphones and 3G. And that really became a data business. And as you know, or certainly will know, that data is one of the real main sources of fuel really for AI machine learning models, or to build machine learning models. That in 2009 actually evolved into becoming a a location-based service. This location-based service helped people find places nearby. So kind of the interest evolved from just finding Wi-Fi to actually helping people find kind of anything that may be of interest. And rather than just being a directory and a data service, it was also a recommendation engine at its core. Obviously, there's a lot of sort of algorithms that go into creating those recommendations, which is sort of the basis of where a lot of my interest developed in what we're doing now. Around 2011, basically, we sort of pivoted from B2C to B2B to basically create a API, recommendation API, to serve like newspaper content and other forms of content online and on mobile. We ended up basically serving hundreds of millions of API calls per month to sort of large media groups. And one of the things that we learned through that experience is that the actual infrastructure that goes into supporting the machine learning models is actually a much larger technical challenge than actually developing the algorithms themselves. Especially as they're starting to become more sort of commoditization and sort of freely available open source libraries that can enable you to build these models. So what I've been building since 2014 is sort of built upon all these different companies, and basically it's called Seldon, and it's a open source machine learning platform with a focus on deployment. So we want to basically enable any data scientist or teams of data scientists to quickly build and deploy machine learning models and to test them and scale them in production. So, life cycle here, one company was acquired, the other one, B2B pivot, the other one effectively bought out, and then, who knows what's happening next year. So, the sort of wild ride of sort of tackling different challenges in the sort of startup world. Another thing, if you read my the sort of bio on this for this event, there's a little sort of side project which actually sort of inspired me to kind of go ahead and do Seldon. It's called Genome Laser, and actually, whilst it's not directly related to sustainability, I think just some of the concepts here kind of have some sort of interrelationship to the discussion, and also actually this group as a whole, because futurists basically, or people who are interested in sort of discussing the future very early on, at the start, some of the concepts and ideas may sound crazy and audacious, but actually, by sort of having these discussions, kind of crazy things can happen and things can actually happen. So this particular experience around 2013 basically started thinking of an idea of basically sequencing human genome, and as this, a connection who has a sort of sequencing firm, and then basically combining that data with some creative coding to basically create a laser which fires that genome, up into space. And first it was just kind of a crazy idea, but it started to sort of pick up some steam as I started talking about it more. And within a few months, actually a few weeks even, a team started to assemble around this who started to say, okay, well, one of the guys is a creative coder at Google. The other one, also many years of software engineering expertise, basically pulled together to actually start building this thing. And we put out a campaign online to sort of get the necessary equipment to sort of to actually convert the signal to the appropriate sort of strength to actually work in this environment. And just started to pick up steam. And before we knew it, we were featured on Wired, and Huffington Post was sort of the main places online. Through that, a guy contacted me and said, I really like what you're doing. I'm based at top university in the US, and I work with a guy called Dr. Charles Towns, and he just so happens to be a very esteemed scientist. So he was the chairman of the Apollo moon landings, discovered the first sort of effectively like water, in space, figured out there's a black hole in the Milky Way, founded SETI, interferometry, whatever that is, measuring the size and shape of stars, and basically, advised, various sort of, very important people in society, and so, what ended up happening is this guy obviously worked with Dr. Charles Townes, and the final thing that he did was, invent the laser. So he was the perfect candidate to be sequenced, and basically about a couple of weeks later, we sign off all the necessary agreements, and he delivers a saliva sample, and we're actually blasting the genome of the inventor of the laser up into space with a giant laser, which kind of blew my mind, just thinking that, that was just, talking about an idea and, inspiring a few people with it, and, before we know it, we've got something that's happening, which actually, although we didn't, communicate with aliens or anything like that, it's just a concept that may inspire other people in the future to do something sort of bigger and better, and actually do something that can have a real impact. So, this is it actually, working, and we had mission patches, as any sort of serious mission should have. So I'll move on to sort of main kind of topic of the day, sort of AI and machine learning. So many of you, or AI and sustainability. So starting with AI, many of you recognize this. It's a scene of DeepMind's AI playing Go against the world champion. And in the end, the computer won. And the reason that this is exciting is that in a game like Go, there are hundreds of possible moves per turn. So if you're to solve this using brute force methods, you'd have to effectively go scanning through each of these different decision trees, and it may seem upon first inspection to be sort of doable with standard computers, but actually and the standard techniques, brute force. But actually, there is more possible board combinations in Go than there are atoms in the universe. So solving Go requires strategy and creativity and forward planning. So there was one particular move which really sort of was a big turning point, and is discussed quite often in this game. It was move 37 of, I think, maybe the second or third game, where AlphaGo actually played a move which all the experts considered to be tens of thousands to one possibility. So it's completely unheard of, and actually then sort of kicked off a sequence of events which led to AlphaGo winning the match. You can see over there Lee Sedol with his head in his hands. He actually had to sort of stand up, go off and compose himself, after seeing this move. And so, harnessing sort of AI, machine learning is really one of the things that's driving the fourth industrial revolution. Obviously this is a world that science fiction writers have been dreaming about for years. Everyone from sort of early days of Mary Shelley's Frankenstein to sort of Stanley Kubrick's 2001, but these ideas, they've been with us for quite a long time. This is not just something that people have been talking about in the last couple of years. This gentleman, Dr. Irvin J. Good, worked at Bletchley Park, and he was one of the first persons to say that the first ultra-intelligent machines are the last inventions that man ever needs to make. The reason for that being that, upon actually creating an intelligent machine that's able to then sort of, invent on behalf of us, we hit a point where, this sort of rather exaggerated but, potentially realistic diagram shows, we're sitting at a point in time where, human progress could just go up, or is going up exponentially, and could obviously hit a point where it goes way faster than we can cope with to some extent. This is a very exciting time to be, and obviously there are real implications across many different dimensions. One of the big ones being that jobs as we know it, are changing. There's going to be huge displacement in many of the jobs which have been very secure over over the last decades. Even sort of not just sort of your blue collar sort of factory jobs that were replaced in the first sort of phases of automation, but also white collar jobs, people working in things like banking and lawyers who are at risk of having their jobs replaced by automation and smart automation through AI and machine learning. So, one of the questions is, will we be living on beaches while the machines do the legwork, or will the model be more like the kind of miners who sort of, put out of jobs in the sort of 80s through the closure of the various, mines? So, moving on from that, let's start to dive into machine learning, and it is everywhere. It's recommending us products online, extracting spam from our inbox, and deciding which of our friends' status updates we should read. And it's doing much more than that, though. It's really helping. It's really changing the world in many ways, from predicting crop yields in agriculture, drug discovery and image diagnostics in healthcare. There's a big company in London called Benevolent AI, which is really focusing on this, and is doing some amazing work. In the energy sector, it's possible to reduce the power consumption in data centers and the national grid, which we'll talk about more. DeepMind are doing a lot of work in this area. In manufacturing, predicting predictive maintenance and smarter robotics within factories. Self-driving cars, which are coming soon. Already some of them sort of in a semi-autonomous way on our roads. And last mile logistics. This is another, they maybe have a place in London, but you'll see some of these like robots on our sidewalk pretty soon. They come from a company called Starship. So it's really helping to sort of handle that last mile of logistics and delivery. So our purpose at Seldon, the company I set up, is to help people predict and shape the future with machine learning. So all of those big problems that I mentioned on the last slide, we want to enable other people to go out and solve these problems. So just moving on to sustainable development, basically the UN put together a vision for 2030. I think it sort of reset this in sort of 2015, where they basically put together, it says here 17, I think it was 17 or a couple more sustainability goals for all the countries to try to hit by 2030, and they're incredibly ambitious. If anyone, if I take a look at these now, it includes things like no poverty, quality education, basically elimination of crime, affordable clean energy. It's very, very ambitious. There's no mention in this entire report of AI, which I think is important, because actually AI, I believe, is the key to turning parts of that vision into a reality. And open source AI is really a big driver of that. So let's start to sort of pick apart what is machine learning, and how is it different from the approaches we've been taking previously. So with traditional programming, you have inputs of some data and a program that a developer has created, and those programs are generally lots of manual rules that are created to sort of deliver what is sort of some seemingly intelligent output. Obviously, a lot of that based on domain expertise, and the output of that is what people consume. In contrast with machine learning, you still have an input of data, but then you actually also input the expected output. So you're training the machine learning algorithm, or the model, using algorithms and basically force feeding it data, and the output is a program, which actually we can call a model. So the big revolution here is that rather than having kind of larger larger pieces of software which try to do lots of different things, it's led to very efficient models being created to solve very focused problems which can be pieced together to create a more intelligent application. So one of the key sort of properties and things to consider around AI and machine learning is this concept of a data network effect. So you'll obviously be familiar with network effects, the classic examples being things like the telephone networks. As more people use it and start having phone numbers, the more useful it becomes. And that's each of those network effects over time has really accelerated. So if you look at things like Facebook and how quickly that built up a network effect compared to previous generations of networks. So the big difference with AI and machine learning is the data network effect allows the service itself to actually become more intelligent as more people use it. So it's not just it's more useful, it's better. It actually is it's more accurate, and that actually does enable sort of large organizations that have access to large proprietary data sets to actually build out a sort of defensibility around what they're building. So let's look at the types of machine learning. First, you have things like regressions. So basically predicting sort of future other scores based upon the data points that are already available. And this wouldn't necessarily just be a straight line. It could be curved lines, and actually in many cases it's effectively multidimensional. Every time I think about multi-dimensions, beyond 3D, it starts to get to hurt my head. But basically that's what we're doing. Classifications, so basically sorting things into buckets, so the green dots and the red dots, and clustering. So given all of these different bits of data, put them into the most logical clusters. And so generally, you use supervised learning for regression and classification, and unsupervised for clustering. The big difference in these two methods is that with unsupervised, you have unlabeled data. So you're feeding in data, but you're not saying what that data is. Whereas with supervised learning, you have labeled data. And that's a really key point. Anytime you have labeled data, it makes life much easier for actually creating machine learning models. And there's a lot of research is going into improving the effectiveness of how data sets are actually labeled. So here's an example of some of the types of problems that you can solve with machine learning. I won't go through each of these piece by piece, but I'll share the slides afterwards. So it's everything from forecasting, classifying, transforming sequences and things like translation, decision making obviously being a very key one, especially in this space around AI robotics, but also things like decision making on sort of larger scale decisions. For companies and organizations that are looking to sort of ideate sort of machine learning use cases, this is a really great tool which you can download. It's called the Machine Learning Canvas by one of our friends who was at UCL called Louis Dorad. So I definitely recommend checking that out. So back onto the types of machine learning. So a lot of the most exciting developments that we've seen in recent years, especially coming from DeepMind, use this concept of reinforcement learning. So the way this works is that you have an agent, which is like a kind of almost like an embodiment, or not embodiment, like an entity, I suppose, within, and that sort of gets set free in an environment. And there is a reward function, which just like when you're training, say, a dog or even a human, you can basically say this like the Pavlov's dog story, that as you reinforce the behavior through these rewards, and that leads to the AI agent basically learning, making up its own interpretation of how the environment works. And in this example here, it's playing classic Pong game. And over time, it's basically learned that the best way to beat this game and to achieve the highest score is to basically hit the ball up to the top here and have it wipe out all of the blocks. And in this example, this classic Atari game example from DeepMind, they never had to train it on tell it the rules of Atari, or even give it any other representation other than a series of vectors which show the colors of the pixels on the screen. So deep neural networks basically, rather than using a sort of statistical approach, are based upon how our brains work. When you are learning things or experiencing things, the kind of neurons firing in your brain basically strengthen the connections. Within a deep learning model, basically you have different layers of these nodes, which you feed through the inputs various labeled data in most cases, or unlabeled in some cases, and as the data goes through the network, it basically forms different connections between each of the layers, and enables you to deliver some output. In this case, you have classifications of people's faces, and in this example, you can see the different layers have picked apart different features, one of the and in the other example over there, it's showing you how a recurrent neural network, so a neural network which is able to kind of has some sort of memory, is basically reading a sign. So actually, one of the points about neural networks is that they are notoriously much harder to explain. Whilst they're much more accurate than sort of more statistical models or things like a like a random forest, which outputs a decision tree, they're much they can be much harder to explain. So another thing which has been picking up a lot of attention over certainly the last year is this concept of a generative adversarial network, or a GAN. And the way that these things work is that you have a generator and a discriminator, which are both like neural networks, and you train the generator on real images, and then you ask it to create new, or it could be any other piece of data. But if you take the example of images, you're training the generator on images, and then you're asking it to create fake data to basically fool the discriminator into believing it's real data. So over time, it gets better and better at that as the discriminator basically tells the generator why, what was wrong about each of the images it's created, until it gets to a point where it can't really sort of discern between a fake or a real image. So this is really useful for kind of generative modeling. In the examples down here, you see GANs have been used to create pictures of rooms within people's houses. All of the faces you see on the right there are all generated by GANs. They're not real people. And another example here is someone using GANs for text to image generation. So this basically says this flower is white and pink in color with petals that have veins, and it's created this image based upon that description. As these techniques become much more advanced, we're able to basically pick apart more data from the images that we're seeing, or the inputs from the world around us. In the first example, you see just a basic classification of a cat. As you add more context, you can see the cat is riding a skateboard, and with a combination of techniques, I think there were like convolutional network, recurrent networks, and something else. Basically, it's able to really pick apart all the details, and this becomes much more powerful when you consider that we're relying more and more on AI to help us in our day-to-day lives. Obviously, we're all using things like Siri and things like Alexa, and these are really great examples of devices which also are picking up huge data network effect. But there are some considerations around privacy, and there's some pretty crazy use cases where because these are listening into everyone's day-to-day lives, whether governments can request subpoenas, and under what circumstances should they sort of deliver that data to hand it over to the government. So let's consider how we'd add AI to an organization. Looking at these main criteria. First, you can build in-house completely. And in this example, obviously you have full control because you're just building it all from scratch. You can evaluate and build as many models as you wish, but it obviously requires a lot more sort of people, data scientists, to actually build these models, and it's expensive. So this is why people build third-party APIs. Third-party APIs generally are enabling you to solve a very specific problem, and so in doing that, you by definition have sort of limited sort of options for how you go about building your model. But it takes a lot less time, and it costs a lot less, and this is why it's appealing for organizations. But there must be a better way, and the third option really is an open source platform. So the reason that open source is so exciting, and so for business and for organizations is obviously still gives you full control. You can evaluate as many models as you wish that's from the open source community, and obviously ones you create in-house. But it takes a lot less time because you're not focused on building the plumbing, and it requires far fewer sort of data scientists to build. So these are the main problems that we're solving really with Seldon. So first, there's huge inefficiencies in that there's no sort of standardized platform for people to quickly build and deploy models. Second, there's $30 billion excess demand for data scientists, and that's just in the US alone. And it's fine for companies like Google or Amazon, but for the rest of the market, they sacrifice some control. So that's why we built Seldon, which is really the building blocks of machine learning. And I'll just show a very quick little video which we created when we were on a Barclays Techstars program last year. So we created a little video demo from our demo day. So machine learning enables computers to solve problems by observing the world through vast quantities of data to spot patterns and build models that are more effective than the programs written by humans. Seldon listens to all of your customer data. You can use it to create recommendations on websites and mobile apps, to predict the behavior of your customers, and to protect your account holders from fraud. We've brought together the world's leading machine learning open source tools so that data scientists can focus on solving problems, developers can create predictive applications, and organizations can get insights faster so they can make better decisions. You can get started with Seldon's open source machine learning cluster. It works on your favorite cloud platform and also on-premise on your own servers. So Seldon is machine learning for enterprise. And the key to getting this software out to a global community, we learn, is through an open source strategy. And that's because the best available technology is open source. Just ask DeepMind that used a piece of software called Torch, and then now uses TensorFlow to build AlphaGo and the things they're working on. Secondly, it gives you full control and enables you us to build a community where people give as well as take. And so when we released Seldon's open source in 2015, we just basically wanted to be disruptive and to get it out to as many people as possible. And we've picked up a community of thousands of data scientists on a large open source community site called GitHub. We have over 1,000 stars and 200 forks. A fork is someone who's downloaded the code and may well decide to contribute back later. And it's available under an Apache 2 license, which means you can download it and use it, and you don't have to even copy your code back if you don't want to, which is better for business as well. So we launched, when we launched in February 15, here's just some of the things that we learned. The documentation is it was a really key concern for us when actually launching an open source project. It wasn't just sort of creating the core software, but actually ensuring that it was all properly documented, and that is like a pretty significant challenge, and because people are not just creating using an API, they have to learn how to install it on their own platform, which actually goes back to the first point that APIs are sort of, or people that build software and sort of SaaS services, they tend to sort of grow roots, and so they're much harder for you to actually kind of sort of take that sort of infrastructure stack and sort of install it and have it run somewhere else. So one of the big challenges was actually kind of thinking of it as a piece of infrastructure and not just as an application, and how to make that portable. The license, which is one of these kind of you can't sort of change this once. It's very hard to change this once it's done. So a lot of consideration, especially when there's various people having different sort of concerns around things like IP and people running away with it, and what's the impact of various scenarios. And ironically for us, it led to an increase in people wanting to sort of have a managed service or a SaaS service provided by us. And we had a few SaaS customers before that, people who were subscribing to an API that didn't leave. We found that was actually the biggest driver of sales. So people were actually finding us through the open source, and that was then turning into sort of business opportunities. And really, the community is a really core part of how you build an open source company. So not just our own community, but with it around Seldon, but also we're doing things like run the London TensorFlow meetup, which is, actually there's two meetups. We run the TensorFlow London meetup. We're friends with the London TensorFlow meetup, and so we have a community event every 6 weeks or so. About 150 people come along and talk about TensorFlow, and we have various technical talks. And so it's very important to give back, basically. So how we generate revenue? First of all, SaaS. So people pay us to have a subscription to the service. We provide support and add-ons that basically enable sort of key industry use cases. Our go-to-market as a open source platform. If you look at these two kind of quadrants, looking at the vertical line being product or service, and then sort of horizontal or vertical. So horizontal meaning that you kind of apply across different industries, and vertical means you basically are just focusing on one industry. So actually, one of the worst places to be as a sort of scale, if you're trying to scale a startup, is like a horizontal service. So kind of providing business services to kind of any industry. And really, in effect, having launched the open source platform, which is very generalized, this is really where we were. So we were the mule in the bottom right. And so this is the holy grail of a startup being sort of a unicorn that has a very sort of productized service that focuses on a very key specific industry. And so the challenge is, do we go over there? How do we get over there? And after spending a lot of time sort of discussing this internally with our team and advisors, and sort of seeing the lay of the land in the market, what we felt the best way for us to go is actually to sort of go up here first and actually continue to provide a very sort of generalized core open source platform, but then just to create a new enterprise product, which is more productized and available on a commercial basis, not just open source. So I'll talk a bit about that. And so only then do you create applications that effectively sit on top of that. And our goal, is not just for us to create a unicorn, but actually for us to give the tools to other people and to spawn a whole, whatever field of unicorns. And so, after launching Seldon's open source platform, we saw huge trends for many of the world's largest companies open sourcing their tools. So the very big one was Google open sourcing their TensorFlow software, but there's many more. And also people are also releasing data sets as well now. So I think there was a DeepMind data set recently, for example, that had all sorts of images of people doing things, and people could use that to build their own models and do their own research. So within the open source community, the steps of evolution we saw were people fixing documentation, then helping each other, and then finally fixing bugs and actually kind of contributing on a technical level. And so one of the core concepts around the platform we've built is around containers. So basically there's a technology called Docker that's really revolutionized the data center. And that's because you have these very portable little images, snapshots of a server, and it's like a virtual machine, but basically you don't have this OS layer down here, so you don't have like Windows or Linux or whatever. So any of the little containers and pieces of code that you've created can talk directly to your hardware, and it's enabled much more of a service-based architecture to evolve as people are creating little services for the different components within their infrastructures, within their architecture for their software, and then creating like little like what they call microservices for these to talk to each other. But one of the problems with Docker is that it's harder for it doesn't have any built-in ways to deploy a whole kind of set of containers in one go. So if you have a kind of complex architecture, you can't. You still need to do some kind of manual wiring up of that architecture. So this technology called Kubernetes came out of Google. It's based upon a project that they created internally called Borg, which is what their engineers use to basically ship software once it's created. So they'd finish doing whatever changes to the software, they'd hit deploy, it would then send the code out to the data center, and basically, if a billion users picked up and started using that piece of software tomorrow, it would just find the resources within the data center. It would scale up automatically. Not a single email would be sent. And so, Google designed Kubernetes as they would if they'd known about Docker at the time, if Docker was available at the time. So, taking this technology into account. So, big thing we're doing now is around data science workflows. So, basically the main sort of constituents of a data science team being a data scientist who loads models at runtime, creates models, and sort of puts those trains the models off things like live data feeds and historical data, usually in like a sandbox kind of R&D environment. They then hand that data over to a data engineer, and the data engineer kind of wears the kind of is the gatekeeper to putting the model into production. So typically they'll be defining, or they should be defining, things like the deployment strategy and the experiments that you want to actually run to see if that model is going to work better in production. Any form of software changes really should have some sort of testing process in place to experiment and see, is this actually making an impact on the objectives that we have within the organization. And those objectives are set by the business people generally, who we've called the data manager in this space, and they create the business objectives, the KPIs you're looking to influence, and then they sort of contract the inputs and outputs that are required. One of to dig deeper into some of the concepts of deployment, and we're moving into what we're building right now at Seldon. So first of all, more advanced experiments. So not just sort of A/B tests where you test one model against another model to see which one works best, or multivariate where you have like a collection of different models that you're testing. We have much more sort of dynamic experiments where you can test a whole set of different models, and it will dynamically figure out which of the models are performing best at that time, and then push the traffic or the trades or whatever it may be towards the strategies that are winning. So the kind of main concepts there of like exploring, so which ones are working best, and exploiting, so kind of funneling the increasing the usage of that model. So this silly image of a octopus playing slot machines, is the concept there is where the name comes from of a multi-arm bandit, which one of the main algorithms, which is where if you think about you walking into a casino and putting £1 in every single slot machine, and then obviously you don't know which ones are going to start paying out until you start observing that some of them are paying out, and then you start sort of visiting those ones more often, but you continue to kind of visit the others. The other big concept around continuous deployment. So this example here of like a canary test, so carving out a little bit of traffic to actually deploy your model to. This is what people like Facebook do. If they've got a new feature, they won't roll it out to everybody. They'll just carve out a % or so of traffic and then test that feature before rolling it out. And the concept of replicas as well. So when you create a model and put it in a container, basically you can scale that up and down by adding more replicas, and then you can do a rolling update by like kind of let's say you've put in a canary of like one replica, and then you've got a few other replicas that are actually running. You can do a rolling update by gradually ripping down the old replicas and adding the new ones, and then you could do all of that at runtime, without having to sort of reboot or do any kind of releases or anything like that. So the other very big thing, a very big sort of area of research also in AI and machine learning is around explanations. So the models in most cases are very hard to interpret, and so take this example here of a model to detect or decide what medical condition someone may have, and you give it some data that you're sneezing and around your age and fatigue and whatever, and then it's saying that based upon and you have the flu. And so the explanation of that, the explanation of that prediction of the flu comes from those features. So another example of this is from a paper called Lime, where this is an image classifier of a guitar, a Labrador playing a guitar, and it's predicted 3 main classes of electric guitar, acoustic guitar, and a Labrador. And the explanations are sort of shown here by sort of switching on the patches of the images which cause those classifications. Okay, so that's going to be really important. This whole concept is going to be very important around data protection and having to explain. There's a thing called GDPR, which is coming into force next year, which forces people to explain their algorithmic decision making. So this product for data science teams will enable workflows, advanced experiments, continuous deployment, and model explanations. And we'll be serving that through a sort of SaaS interface, and you can use it to control the open source clusters. It will work a bit like this. I won't go into all the detail here, but effectively there's 2 products that work kind of in pairing with each other. So deploy being the square on the left, which your data engineer uses, and then the core Kubernetes clusters is really where the kind of intelligence service, where the consumers, the people who are using it, engage. If you want to download or if you want to join the beta, you can go here and sign up. So let's move on to sustainable development and see how this can tie all this together. So sustainable development really, it's about making the world better for future generations, ultimately. And there's sort of three main dimensions that we care about: the environment, obviously very important, the economy, and social welfare, right? And really, from what I've read and what I agree with, that the environment is really the kind of the biggest one on here, because if you screw that up, then the others are not going to do so well in the long run, and it's harder to reverse, obviously, as well. So what are some of the impacts of technology just generally on the environment? So you get these first order effects, basically, where upon sort of creating a new technology, it leads to a sort of a negative impact on the environment. So increased production, increased energy, greenhouse gases, waste, et cetera, et cetera. As technology improves over time, and sort of second order effect or higher order effect is related to sort of new technologies emerging, which actually offset some of the things that were wasteful in the past. So if you think about things like video conferences, like a lot of us reduce our travel now because we can speak to people as if we're in the same room pretty much, or more efficient energy uses of energy, smart grids as an example. And then the third order effects really is can be positive and negative. So the increased usage due to the increased availability actually can net sort of have a negative impact. So it really differs from one thing to another. But let's take a look at Google's data center, and a use case which I think I find very inspiring in terms of how what impact AI can have in what is really one of the world's most sophisticated environments. So in this environment, the equipment all interacts in a nonlinear way. In other words, like it's not always clear if you turn the temperature up 2 degrees exactly what's going to happen to all the other variables, or down by 2 degrees or whatever. When people actually define sort of the DevOps people define strategies for reducing power consumption, they may have a hunch as to what's going on, but because it's so complex, it's very hard for them to sort of model properly all of the different interactions between the different components. Things change, right? So you have you don't have a real consistency between all the different components in the data center. Maybe the weather changes outside. Maybe you install some new types of hardware which are more or less efficient. And each data center itself is unique. So Google could create a model for one data center, but and then they can't take that model and just plant it directly into another data center in another country. So which makes life incredibly difficult for if anyone was trying to code this manually. And I just made that point. So actually, this is one of the things that DeepMind did after they were acquired by Google. They went in and were helping to solve these big problems across Google. And so what they did in the data center is they applied neural networks, which they trained on all of different ops scenarios and parameters. So all the log files and stuff that were being churned out from these servers. They had access to vast amounts of historical data. And if you consider that this is like one of the most sophisticated environments with some of the most sophisticated engineers working on it, you'd expect that maybe they were previously able to make marginal improvements of like 1 or 2% max. In this case, they managed to reduce the cooling bill by 40%. So pretty game-changing development there. And so one of the things that they're talking about at DeepMind now is how they can apply this to national grid. So I don't know as much about exactly what they're doing there, but basically, let's have a sort of consider what's out there, and if you consider first the North American electric grid, it's actually like an ancient creaking piece of infrastructure, and it has many hundreds of thousands of different or millions of different parts to it. A few very large AC grids, 20,000 generating units, so like power stations, and areas which are actually creating energy. Although that's relatively pretty small, considering the way that trends are going for energy generation. Basically, this network has over time become less and less reliable, and it's basically less attractive to investors also to basically invest in improving this infrastructure. So ripping it all out and sort of replacing it with a new centralized sort of electric grid. So a couple of other intersecting trends around sort of energy generation and storage. So actually, there's been a massive reduction in solar power costs over time. So I think this over here is the 99% fall in the cost of solar since 1976. And meanwhile, the watts per kilowatts per hour, I think it is, of those devices of in-car batteries, I believe, or if actually just general lithium-ion batteries, has increased about 7-fold since 2008. And so, this is really great news, as it enables us to both collect energy, much more efficiently, and store it at the endpoints of the network. And so, you will, I'm sure, have seen people like Tesla, Elon, announcing their not just their big battery packs for storage at the endpoint in your house or office, but also these smart tiles which they announced recently, which look like tiles that that you already see, and not ugly kind of big solar panels, and they argue that the cost of ownership is less because if you consider the energy cost and the energy savings of running with these tiles, and this is first generation, obviously. So pretty exciting, and so this leads to an opportunity around smart grids. So as more energy is created at the edge, basically, you can see that obviously there's an increase in solar jobs within the US. So that's increased, 25% year on year since 2016. So one in 50 jobs in solar. I mean, that is pretty staggering. And a third of energy generation will be sort of generated at the endpoint by 2020. Already 10% of consumers are deploying on-site energy generation. And basically these grids will be growing basically up to 15 million assets, which is obviously massive growth. So the big opportunity, one of the big opportunities here is that there's this concept of what they call the EnerNet, which is basically like having where you have all the energy produced at the endpoint, and smart storage or storage of that energy is this opportunity to basically arbitrage between those different endpoints in more of a network, rather than having this sort of central point of distribution, you may pull down some energy and you're out and you're not using that energy for for the day. Maybe that your neighbors are having a party or doing something, and they end up basically taking the energy from you rather than pulling it all the way back from the grid. So working in many ways how internet protocols work rather than sort of classic energy systems. So the thing that's really powering this is this convergence of both like energy consumption and also IoT devices, which are running at the endpoints. So we'll move on to manufacturing. So there's an interesting use case here. A Chinese manufacturer called the Chanying Precision Technology Company. And basically recently they replaced 90% of the human workers with robots. And actually that led to a rise by 250% in production, and defects dropped by 80%. So take another example here. So this is like, can anyone tell me what this is? Sorry? A worm. It's close, actually. It's basically, these are all this is a cucumber classifier, right? So, someone based in China, I believe. Actually, no, it was Japan. It was a Japanese cucumber farmer. Basically downloaded TensorFlow, free piece of open source software, and they used commodity hardware that you can pick up, things like a Raspberry Pi for a very, very small amount of money, and basically pieced it together to create this kind of automated, effectively like factory conveyor belt, which is sorting the cucumbers on his behalf, which obviously means he doesn't have to do it or doesn't have to employ someone to do it. And obviously that was not something that would not have been accessible a few years ago. And so if that can be pieced together with pretty sort of rudimentary software and hardware, or commodity software and hardware, just think about this on a broader scale. So this is basically a more advanced version of that cucumber sorter. So this is a device that actually was retailing for more in the kind of $600,000 range from a company called Zen Robotics. And basically what this is doing is the same kind of concept. It's got a classifier with video cameras and robotic arms, which is basically sorting through your waste and picking out the different pieces so that they can take them off to be recycled. That's one of the biggest problems in waste management, is just everything just gets jumbled together, and so it's kind of easier to landfill than it is to sort it all out. When you send your iPhone back to Apple now, they'll do a similar kind of thing, breaking it all apart. And really, this for me seems to be one of the most logical sort of solutions to waste management now, is that just to basically as the cost of robotics goes down and the labor associated with that, I think any country really should be pushing waste through similar machines. So I think I'll finish on kind of a fairly theoretical concept, which hopefully will promote some discussion and debate here, and maybe kind of some other ideas that you may have around this. So basically, if you consider that the concept I told you earlier around the Google data center being a big nonlinear problem, and really sustainable development in itself is a very big global scale nonlinear problem. So across those different dimensions of the environment, social, and the economy. And there's lots of data that's basically associated with all of those, but it's all kind of spread apart. So basically, one of the keys is to really try and integrate all of those different indicators and try and pull together data that is being held by things like the World Bank, via various sort of government agencies, via publicly traded companies, and sort of when you're creating models, basically train it on the sustainability goals, the outcomes that you're looking to achieve, so it might be that you promote the environment slightly higher than other factors. So so rather than just kind of taking the output of these models and just having it automatically run through an automatic sort of decision-making government sort of machine or bot or whatever, have it figure out new strategies for solving big problems, and then use that to augment the decision making. So these are some diagrams from actually a research paper that I thought was pretty interesting, which really inspired a lot of this. It was written back in 2008, before we had anywhere near the same level of sophistication in things like AI and machine learning. So they were basically stage one. Sorry, just go back to this. Stage one, basically creating or training these different networks separately from all the different data points that are available. I don't know if I can zoom in on this. Oh no. Okay, never mind. I will share the thing so you can actually see a close-up image. Then phase two is to basically train here is a multi-layer perceptron, so a neural network on each of these different sort of separate dimensions. And then the third stage is basically to pull all of these dimensions together. So you can imagine there'll be lots of different agencies that are generating these nets. It's not going to be just one big global sort of push. There'll be hopefully the standard, and people would be all feeding into the same system, which ultimately should have these benefits. So obviously building an AI model you're building an AI model here for what is inherently a very complex system, which has various factors spread across these different dimensions. By creating models, you're better able to simulate potential outcomes as well, that can, and by not just predicting but simulating outcomes, you can help people make better decisions ultimately. With things like what if kind of statements. You can then actually, in policies where you're actually sort of distributing some form of resource, you can do that more effectively between states and within things like the EU. And you can also sort of anticipate, identify issues sooner before problems emerge. And then actually it is also possible over time, because of the nature of how neural networks and AI do evolve as you add more signal, and in the same way here, as we sort of pull more data into this, this system, it gets better over time, basically. So actually, that's the same diagrams as before. So I'll conclude on a few points then. So really, like, AI is the key for that UN 2030 vision, right? On the micro level, it's all about the optimization of problems. So, things like the cucumber farmer, it's very sort of, focused problem solving, but it uses AI. On a macro level, it's all about sort of augmentation of human decision making and policy making ultimately as well. And final point is really that it's no single entity really can drive this progress. It's done by a collaboration between between technology creators, companies, open source software and data, large community of contributors, and collaboration between the government and corporations. So yeah, these are just some food for thought, really. When I retire from Seldon, maybe I will go on and try and execute on some of this. So yeah, my name is Alex Housley. We'll obviously have Q&A, but if you want to contact me, that's my information. Okay.
Thank you very much, Alex. Well, that was a real tour de force. You mentioned that there's no mention of AI, it seems, on the United Nations list of the Sustainable Goals. You mentioned also that you have provided in Seldon a series of frameworks, interfaces, packages to help people to apply much of the cutting art, state of art in machine learning to a whole bunch of different areas. So are you actually now getting engagement from sustainability advocates, from non-profit groups to try and see how they can plug into your systems to start exploring some solutions?
So there have been early signs of interest, like direct interest that I've seen. One of the events that where we met earlier this year, and actually how I picked up a lot more interest in this topic, I was actually invited to speak at this Sustainable Development Forum event in Cambridge. And my focus is very much on mainly the business aspects of AI, and but I had an interest in just how can we help people solve these problems, and that's when I started to do a bit more research into what is really sustainability, what are the stuff I went over here. And actually, I was happy with the feedback from that event, as there were people who, are in some of the agencies I mentioned there, who, I'm now connected with. I can't say that I'm directly pushing those things right now. The reason for that actually is just purely economic. Like we're a startup trying to get from, I suppose we got from 0 to 1, but to get from 1 to n it can be pretty tough, and it requires focus. So where we are focusing initially is on financial services and banking, and although that is basically in many ways contradictory to a sustainable development business, actually it requires us to build some of the most robust infrastructure that that you would ever need. Bank grade, a sort of AI machine learning system, with the regulatory requirements and the scale and everything else, actually enables us to build, and the throughput that's required and the availability really enables us to transfer that into other spaces. So that's where our kind of team effort is right now. But in the long run, we do want to kind of carve off and actually focus a lot more of our attention on solving these problems as it's very close to our core principles within the business. So yeah.
But given that you have an open source platform, you're not actually holding up other people. You're not preventing
exactly,
other people from getting
so
involved.
that's a great point. We do have thousands of people using Seldon across industries and in academia. So I would hope that there are some people already using Seldon to tackle some of these sustainability challenges. Obviously I would encourage anyone here who is interested in tackling these to talk and use Seldon. So.
One last question from me before I open up to the floor for comments and questions. You listed 3 areas of where sustainability might go wrong, one of them being the environment, one of them being the economy, and one of them being society. Mm-hmm. And you looked at ways in which deep learning might improve the flow of energy and recycling of waste, which looked very encouraging. But what about solving the economic issues? I mean, people argue like crazy about the effects of different taxation systems, the effect of universal basic income and so on. People say that's a very wicked problem as well. So there's the economy and then the society, which is people's attitudes and expectations and perceptions of feeling worthless and perceptions of being a part of an unequal society. Do you think it's credible that deep learning might be able to come up with models for dealing with new taxation systems, new flows of wealth and new flows of ideas around society? Yeah,
that's an interesting thought. I hadn't considered that that AI could create the most efficient tax systems. Actually, it's a very good idea.
People talk about why don't we have a driverless government,
Yeah,
Currently
exactly.
the humans are getting in the way.
Yeah.
There might be a lot fewer crashes if there weren't humans trying to put their hands on the wheel and steer it one way or the other for political purposes.
Yeah, indeed. I actually, on that broader topic though, I think it is important to be very sort of prudent about like the potential impact. It will inevitably displace a hell of a lot of jobs over time, but also when you look back over the jobs of even 10, 20 years ago look a lot different than they do right now, and we've evolved. And so I do think there's 2 things. One of them is an evolution in people who are currently skilled, adapting those skills to other areas which may not be sort of programming directly, but maybe there will be a job, a job that is effectively helping to train new intelligence agents, intelligent systems. Like one of the things, just a little case study, when we went into a law firm for a project, for a proof of concept project, where we were looking to create a kind of an agent that's able to, or a chatbot effectively, that's able to take questions and answers on legislation. And they gave us a pack of legislation, and they basically said, okay, here's the questions we want you to answer. And so we looked at it, we thought, okay, this is a very interesting project, but we're going to need like 100,000 examples of questions and answers related to this piece of legislation. And when I went back, and they were like, actually a little bit surprised that we didn't just have a sort of magic AI wand that would just sort of create the algorithm. That is a big job for them internally to actually go out and source that. I mean, some of it is about working it into the workflow day to day, but there is also a job of effectively farming data, creating data sets that can create more intelligent systems.
And just on that point, I can't help but ask about possible learning from small data sets instead of big data sets. Because famously it's said that current algorithms make a wonderful job because they get huge data sets, but humans often seem to be able to infer patterns with much smaller data sets.
Yeah.
Is there any possibilities for a next generation of artificial intelligence that will be able to do the same as humans and therefore infer the principles from smaller sets of data without needing to generate millions of questions and answers to train the system from?
Yeah, I mean, it depends on the environment as well. If you're talking about things like natural language and like kind of interpretation of questions and answers, those things do generally require larger amounts of data sets. But most of these concepts that you see are effectively building blocks on previous levels of abstraction. So it's much easier for someone to create chatbots now based upon existing chatbot engines, and then there'll be various natural language models that have already solved most of the day-to-day intricacies of language. So it does make things a lot easier. And actually, as an interesting blog, I'd recommend just Googling. It's actually called something like You're Not Google. And actually, one of the big things in technology and VC is that people engineer their software as if they are Google, and actually like using the same kinds of infrastructure that can support billions of transactions, when actually in reality, in many cases, you can work with much sort of lighter weight components to start with.
Questions from the floor. If I can ask you to wait for the mic, because otherwise you won't be picked up for posterity on the recording. This also helps to control the flow of discussion.
Yeah, hi, Alex. Thanks for that presentation. It was excellent. Really enjoyed it. It actually was a point that you made about teaching AI systems to sustainable goals and strategies to make sure the outcomes are right. And I've been thinking of that in the context of some of the statements you've heard over the last few years from people like Professor Hawkins and Elon Musk as well around AI and the threat that it potentially poses to the world. But I also was thinking in terms of the recent DeepMind example where the gathering, where they had the game that they was teaching the AI to hunt for apples, and they gave them lasers to see whether they would cooperate to gather the apples or whether they'd compete effectively. And it turned out the more complex the AI got, the more they used the lasers
Right.
and became quite more aggressive as it went through the process. It was quite an interesting outcome with it. So to me, I think that your point about the training in the sustainable goals and strategies is going to be not just sustainable goals and strategies, but positive, how do we train into AI systems the greater good, or for positive outcomes rather than turning into a dystopian nightmare, basically.
Yeah, that's a really good question. So I definitely would agree. Yeah, that it's important for AI to be respected as a technology that can can do harm as well as good. One of the things where I look at this is that most, pretty much all technologies that are developed can be used for bad and good, and that's nothing new. Like if you look at everything from early tools that were used to build stuff that could be then used as weapons effectively, or in more modern days just software. We're going to banish computer software languages because you can use it to hack and write viruses as well as code that run hospitals and things. So I think that ultimately there is this kind of cat and mouse game as more sophisticated technologies available. People will seek to leverage that to cause harm, and then there is actually an industry in a way that forms around circumventing those things from happening. One of the kind of core things around sort of AI models at the moment is that they are very narrow. I didn't make this point earlier, but really we can actually achieve a superhuman output, but it's only a really focused domain. So you say to AlphaGo, let's play chess. it wouldn't be able to just get up and play chess. You know, it's specialized to AlphaGo at that point, or the model is at that point. There is a lot of work going into transfer, a thing called transfer learning, to move from one task to another, and there is some good progress there. But I think we're still a way off, a more broader artificial general intelligence. But then even in those contexts, I know a lot of it's still theoretical at this point, is that there is a kind of objective function. So, where a AI has kind of the keys to the Ferrari, is like kind of able to actually influence significant systems, there will be the people who have a moral standard that set those objectives, and I think that will go some way to preventing sort of the kind of Hollywood kind of scenarios of robots and AIs really sort of just deciding to take over. But yeah, I think that an area to really be careful is around weaponization, though. So, already there are autonomous drones, and effectively the kill decision is not made by the trigger of someone pulling the trigger, and that really kind of already happens. So yeah, that is the area that I think needs the most care taken, and it's sort of obviously separate from the sustainable development stuff, because that's although I suppose it figures somewhere in this like society, it's kind of it's slightly different.
Question here.
Thank you. Before going to the nightmarish scenario that you just mentioned, I would like to go back to the Chinese car factory. What happened to the people that have been laid off and been replaced by the machine? Because you mentioned the EU level of discussion. There was a discussion about outlawing robot because they might have taken over the workforce. And so people would have nothing to do and actually no money. And this differences between the super rich and the super poor not only will increase, but will also kill the people without a job. So within the context of sustainable development, this in the future, which is already happening in some parts, maybe in China and certainly at Tesla, what is going to happen to all those people that will not have a job thanks to AI?
Yeah, that's a good question. I don't know in that specific example, and actually I put that up as a really interesting case study that what sort of decision-making process that people who run factories have, if they have seen that this is the kind of potential economic gains that they can have by integrating robotics and automation to this level. I think on one hand it's one of those things that it's unavoidable. It's a matter of time, and in terms of you can try and regulate and slow down progress, but that's not going to happen on a global level. Companies will continue to create techniques that displace existing jobs. Another theory, which I mean is a separate one on what people will do, and this is not grounded on any real like data points or anything. Is really just looking back at like what do wealthy people do with their free time, and actually like very few would be sort of just consuming digital content and stuff like that. Like actually there's a high premium that's put on analog experiences, and those analog experiences, like eating out in nice restaurants, listening to bands and music, and having sort of people like look after you in some way, in a hospitable way, right? And so I think there would be effectively like a big services economy that will emerge from the people who have been put out of factories, that will effectively be like as also the wealthier people have more time on their hands as well. Effectively, they'll be spending a lot of their time on holiday, right? And I think that's possibly one area that we'll see, but that's again grounded by no kind of serious data points.
Another question is whether the people who are on holiday would prefer to be served by humans, or whether they'd prefer to be served by robots that are cheaper and make even better conversation and don't get in the way. I guess the two questions are actually the same in a sense. There's what is the ultimate objective? And what objective do we set for the robots or the AIs so that they serve humans and don't just pursue some narrow-minded objective like kill all the bad guys? And the question here is, what is the objective we set for society? Because currently our objective seems to be maximize GDP, and we're very good at maximizing GDP, and all the other things don't come along very well. But let me give the microphone to a few other people.
Thank you. I'm interested in the configuration management of these systems, and I think in a way that may serve to answer some of the other questions that have been raised. In fact, in one of your slides, you mentioned that one of the goals of one of the systems you were talking about was to train human experts to become better at understanding the systems that they were being helped to manage by the artificial systems. And this business of neural networks being notoriously hard to explain, I think, is part of that problem. And I wonder whether you've got any deeper thoughts about how that problem might be addressed, because I think that may help to spread the knowledge that's being accumulated in those systems and allow people to work with them more confidently than they otherwise would.
Yeah, that's a good. So, I mean, I think part of what you say there touches upon the kind of things we're trying to do with Seldon. Is really, make it much easier for people to focus on creating models rather than, and as part of the deployment process, there is a big kind of configuration management sort of piece. One of the and that's configuration of like algorithm and model selection. But then each of the models themselves have these sort of hyperparameters associated with them, or parameters associated with them, which can be tuned to sort of improve the performance for whatever objectives, whatever metrics you're trying to optimize. Another thing slightly related, I think, still is and maybe also touching on some of the other points is. So I didn't mention today this whole concept of humans in the loop. It's kind of inferred, but the idea of like, as the AI systems get more accurate and better as they gather more data, and that data obviously is in many ways created by sort of the implicit actions that people take. But then there are also cases where, I gave the example of labeled data being so important that, that's not available. So creating better interfaces for people to engage with an AI and train AI is I think, a big interesting area of development as well, which kind of makes it more accessible as a tool than just something that AI and machine learning researchers can use.
Thanks. Your point about the Chinese factory kind of replacing the 90% of the human and productivity increase, and defect has also significantly decreased. You also mentioned about self-driving cars.
Yeah.
I presume something similar, so hopefully accidents will decrease as well. Now, it seems to me that we may be decreasing the chances of accidents or defects, but when they do happen, they could be something really, really bad. So for driverless cars, we may be able to, AI or machine learning or something can say, on the motorway, the cars can be really, really close to one another as they drive. But if there's some really, really kind of unforeseen bugs, then maybe 100 cars can crash. So it seems to be kind of risk will be a lot more binary, a lot more low frequency, but really high severity. So I'm just wondering what the data scientists, data engineering manager, etc. community is doing to kind of manage these risks. How are they going to challenge one another to produce more, let's say more, let's say more professional way of going about things, more robust, etc.
Yeah. So I think that particular space around autonomous cars, transport, leads to some pretty significant moral issues, right? And I think many of you will be familiar with the whole like trolley problem, right? So if the example there, if you're driving along and if a train is driving along a train track and it has the choice between carrying on one track and mowing down an elderly person, and if you could change the track, it would like kill a child or something, like those kinds of moral dilemmas. What would you do? And so, but it's on a track, so it's going to do one or the other. You can't just stop it. So those are the decisions that in these very high pressure moments of accidents, people steer one way or the other, and in many cases, I suppose will ultimately try to preserve their own life, right? But then maybe they won't. It's just such a difficult moral dilemma. And I think the way that I personally within Seldon have not been involved in software which has to make any of those kinds of judgment calls. So I think in a way that's I'm not super qualified to answer the details of that. What I can say from some people I've spoken to in the sort of self-driving car space are looking at it purely, trying to actually just remove the complexities of the moral question and just count human life. So if in plan A, option A, you kill 2 people, in option B you kill 1 person, they'll take option B. And there's nothing else that goes into that. They won't discriminate on any other factors. And that's actually simpler to code. The second part around managing risk. I would first of all, if you look at the accident rate overall, using AI versus humans, to take driving again as an example. I'm not going to give you any specific stats here, but let's say you reduce the accident rate by 10%, whatever it might be. Reduce it from reduce it by 10%, which is saves millions of lives. The issue is, one of the issues is that because these things are new, that there'll be a lot of bad publicity associated with those crashes, more so than what we are used to on a day-to-day basis of people actually getting knocked over and hurt all the time. So there will be a period of bad publicity around the accidents that do happen. But actually, there will be a clear economic incentive for people building, these systems. That's why I think people like Tesla obviously had a big incident. One of the only notable death I think they've had in many millions of miles driven was a serious incident for them, and they obviously have been working on making those improvements. So I definitely would argue that it will be somewhat still driven by the economics to ensure that the risk thresholds are acceptable, and Yeah, I think that's really.
But
the main
perhaps the risk is that a much larger accident might happen if
Yeah.
there's a bug in the software which some hacker is able to exploit.
Yeah.
A bit like the way that so many NHS facilities were shut down by a single bug that had been present and hadn't been patched. And it was sort of hacked almost unintentionally by some source we don't quite understand yet. Maybe there will be a much worse disaster due to self-driving cars than any series of human-induced accidents. Therefore, a higher caliber of safety and risk and security management is
absolutely.
required.
Yeah. So yeah, exactly. Yeah.
And just to add a bit to that discussion, I think I saw a talk where Elon Musk was saying that our standards for self-driving cars safety, we expect them to be like 1,000 or 10,000 times higher. And part of it is to do with, because we're letting go of control. So like your standards for aircraft safety are much higher because you're not the one flying the plane. So it's kind of equivalent to that. So just coming back to the macro level AI, which I'm really interested in that aspect of the potential future. And so I guess global sustainability it's a commons problem. It requires global coordinated effort, which is one of the things that makes it particularly difficult, especially with various different political contexts. So could you propose, are there any like reasonable kind of smaller training grounds that could be used to kind of test such concepts of a macro level AI? So I don't know, a city or a company or product. How would we go about like trying out those ideas on a smaller scale?
Great question. Smart cities is very interesting, development. I haven't mentioned it here, but that is there's a lot of research into how we can make our transport systems and everything more efficient, energy and everything more efficient. The way I was initially looking at this is where can we source good open data sets and which that we can use to generate some signal and really use that as a starting point to make maybe some predictions on on future events and outcomes, and on the basis of that, one of the approaches that we've taken, going back pre-Seldon and in the recommendation space is this concept of like precision recall, which if you take a data set, you chop out 10% or whatever, use the rest of it to build your model, and then you effectively try to see if you could predict the things which happen next on the basis of that. So there's there's a basic kind of prediction problem, and then there's your kind of policy-based processes as well. The difficult thing is with policy-based processes, it's harder for you to actually test those using historical data, and you can. There can be a kind of overfitting problem. So there's a classic example of Google doing its flu predictions. So it was basically claimed that your Google searches enabled them to predict flu, better than any other system. And there was a lot of PR about it initially, and that model worked incredibly well for that moment in time. But there was a problem of overfitting ultimately. So that model, the data was incredibly good at that for that specific data set and that specific model. But as soon as you add more kind of data and noise, that model becomes ineffective. So I think that the bird flu outbreak happened a few months after, and it completely missed it, and it was like But I mean, I would say that I've given this some thought, but I've not gone as far as sort of digging into like the real core of what data sets are available and running hackathons and that kind of thing. I would encourage definitely anyone to sort of try to find for appropriate data sets though for any of those three main dimensions as a starting point, and maybe start to try and predict some potential future outcomes.
Thanks, Alex, for a great presentation.
Thank you.
Quite connected to the gentleman's question here. So I work in sustainability and human rights, and I sit on a massive chunk of data. So I work for a company. We do an enormous amount of inspections in the supply chain, factories, logistics, whatever, on social and environmental data. And our challenge is really to make sense of that. My challenge is really just to answer the question, do I know under which conditions our goods are being made and or handled? And right now that is a very manual process. A lot of it is qualitative data, and then it passes through me and my team, and then that's supposed to end up with a prediction of risk, and then from that a response.
Right.
So that's really the micro level of that question, I think. And my question to you is just, where would you recommend someone like me to start to see, whether you can deploy AI to support risk prediction and decision making in this particular case?
Yeah. Okay, cool. Great. So I'd love to talk afterwards as well. But basically, I think this applies just generally to what we're doing. Within Seldon, we're building a team of machine learning experts rather than necessarily people who have deeper domain expertise. And actually that's fine, because when we go into an organization, for example, we've been focusing on financial services in the last year. We go in and we speak to the stakeholders within that organization, and we basically convert their domain-specific problem into a machine learning problem, and we kind of tackle it in the same kind of way for each. So, for example, let's go back to the finance example. That within banking, the most sought-after skills over the last few years have been, effectively economics and finance. But now, really, they're looking for technologists, developers, machine learning people, and so the main ingredients that you would need are, I think initially to figure out which use case, which problem or problems you could potentially be looking to solve that actually, have an impact on your organization. We always find it's important that you have effectively people taking ownership of that problem, and the project, and actually sort of having sufficient kind of organizational buy-in, right? So if it's a side project which doesn't really have support from the main sort of decision makers, it can kind of get pushed to one side and not really sort of pushed forwards with enough effort. And did I say then data sets as well, obviously. So just ensuring that you have the data to match the use case that you're looking for. And then also there's some kind of initial analysis that you can do, or you can read about, or we can help to establish if that data set is actually going to help you to solve whatever use case you're looking for. One of the key points is this concept of is there labeled data, or in some cases, for example, is there a target variable? So if you take something like risk on a credit card transaction, or credit risk, so identifying which customer accounts are likely to go into arrears, what we do there is we take a data set of credit card transactions, which are all anonymized, obviously, and identify which customer accounts actually did go into arrears. So the target is missed a payment, and if you don't have enough of those missed a payment variables, the target variables, then it's very hard to build a quality model. And actually, that kind of thing, so that's maybe helps to answer even your much earlier question about size of data set. if you've got a really massive data set but very small amount of target variables, then actually it's going to be very difficult to build a model. But if a very small data set with enough quality examples of what you're trying to train will enable you to tackle that much more effectively. If you don't have labeled data, then you can still look at sourcing other third-party data sets. Like one of the things that hedge funds do quite often is try and source other data sets that are more on a sort of macro level, and then are trying to apply and spot the patterns between that and micro level. So things like satellite imagery would be one example there, or just other sort of production data sets.
Hi. So it occurred to me when you were talking about autonomous killing machines, like drones, sort of being out with humans out of the loop, and it made me think about computer games like Call of Duty and things, and they seem to have quite well-developed narrow AIs in the computer games industry. And then that sort of made me think about some other computer games like The Sims and Civilization. I played Civilization. And then it made me think about things like these massive online multiplayer role-playing games. And I thought, could you not use those, if you could tap into them as data sets to consider how societies might work, and then use AI maybe to come up with models that might optimize society based on whether you wanted them to get the highest GDP or happiness or sustainability, and just as a starting point, come up with ideas that might help, society become more sustainable.
Yeah, it's a really great one, actually. And the concepts that you're talking about there of, first of all, having taking influence from computer games. I think a lot of the developments that we've seen in AI actually have initially come from gaming. Even things like GPUs and from a processing perspective, and a lot of the sort of earlier AI, effectively like kind of more rules-based AI initially, but very sort of intricate models that have been created in a gaming environment. But there's two other big trends which I touched upon slightly. Simulation. We're not at Seldon a simulation company per se, but we have there are applications of AI within simulation. And so the way my understanding of really this working is similar in many ways to this reinforcement learning concept that obviously mentioned earlier around an agent, just like an agent maybe could be Super Mario running around in a game. Multi-agent based modeling is really kind of some of the main building blocks of simulation. So the company actually that was also on the same Techstars program as us, the Barclays one, called Simudyne. It's worth checking out, and they specialize in sort of large scale simulation with agent based modeling, and so the concept there is you kind of take your time to model those individual different entities within the system, and then based and then sort of train it on some historical data of what's happened, and then let the simulation run as a way of asking these kind of what if questions. So they're doing some work with large banks and sort of creating various sort of economic models off the back of this. I think it makes a lot more sense actually for certain economic modeling to use that kind of approach than to try and spreadsheet the sort of intricacies of an economy. And I think that's where we'll see a lot of development. And then the other big one, which I know a bit about, not actually played with it though, is it's related to that. It's around virtual worlds, and those simulations. They can be effectively like abstract simulations in some of the sort of economic examples, but they can also be rich, immersive simulations. And a London-based company that's massively innovating in this space and just raised about $500 million is called Improbable, and definitely worth reading up on what they're doing. And a lot of their focuses are really around opening up that sort of simulation environment to much larger, much more intricate sort of gaming and simulation environments, basically.
You said something about the overall goal for AI having to be something positive for society and not just for a handful of companies. What would you think are the steps we as a society need to take to actually reach that? Because only making AI technology open source probably won't be enough for that.
Mm-hmm. That's a good question. I think open source goes a long way. It does help. I mean, if you look at most of the developments, most of the sort of the initial research that went into creating the systems that are now used in companies and other government and other organizations, initially were research projects that came out of universities. And generally universities are very open in the way that they publish, and research has in effect been open source for many decades in this space. Then there is a convenient, in some ways, commercial benefit for organizations to open source. Otherwise, it would make sense for someone like Seldon, to open source to try and compete against larger organizations. But clearly, it makes sense for organizations like Google to open source things like TensorFlow, which was a really core part of their internal sort of AI engine. The things that I think people are not open sourcing are the models that are output by the tools, but the kind of the picks and shovels, if you will, are on track to becoming heavily democratized, and already are to some extent. I think it's good that there are there's really a couple of other sort of related topics around, like because of the nature of the types of people who are doing the most sort of hardcore research, coming out of universities and having a more of a need for sort of collaboration with their peers and peer review, that the environment of a sort of overly secretive organization sort of doesn't fit how they want to work so much. So they would potentially go and work with a competitor who allows them to sort of publish more openly or speak at more conferences and that kind of thing. So we're seeing, take an example here, companies like DeepMind, there was a lot of perceived secrecy over the last few years, but they are actively out speaking at events and publishing papers, and are being quite forthcoming about the exact things that they're currently working on. So yeah, I think just continuing to promote that, continuing to have forums where people can share ideas, and things like the TensorFlow meetup that we've created is exactly for that kind of thing. But there's loads of them out there, obviously, and that in a way does provide some kind of insurance policy against a highly competitive environment where people are all blocking into each other, and you end up with a few big dominant sort of monopolies that come from it, or a monopoly that comes from it.
So Alex, where do you think is going to be leading in the world in adopting AI for sustainability? Is it going to be London? Is it going to be the state of California? Is it going to be China or Estonia?
Well, I certainly have less yeah, I'm less inclined to say the US since Trump sort of came into power recently. Although
we've gone the whole meeting without mentioning that name.
Yeah, exactly. There's this, yeah. So no, that's one of my like kind of slight caveats on this whole thing is like actually, this all sounds really great in theory, but you know ultimately there are you know seemingly like unrealistic or like you know insane decisions that can be made by people in power. So you can't always sort of allow for that in like you know these sort of systems, but you obviously can try and do your best to suggest and create systems which can, if everyone plays ball, you know, work well. So I do think overall that you know London is as better placed as any you know country really to sort of lead the way in this, and you know. Obviously, yeah, I think that this is a perfect place for people to tackle these issues, but it will take a global, you know, coordination in order for AI to be used on a macro level.
So we'll ask the audience to thank you in a minute. I'll just give an answer to that last question as well. What do we need beyond the wonderful enhancements to technology and sharing open source? When London Futurists explores these questions, and I think we need to review how democracy is working and bring some of the lessons of open source into the world of democracy so that democracy benefits from the wisdom of the crowd. And we're going to have a meeting in September in Birkbeck College in another building, not this one across the square, in which a whole bunch of people, many of whom are connected with politics in one way or the other, are going to be looking at this question of what else do we need to do to ensure that we have a better future. The technology is indeed a very important part of that, but maybe there needs to be reforms to political systems as well, and the changes in our values. So I encourage you to explore other things that London Futurists are doing. I'll leave this running in the background shortly. You can see the other events we've got lined up. But for now, it comes to me to thank Alex very much for being brave enough to address a whole bunch of questions which he said he wasn't entirely sure he knew all the answers. And that's exactly the right thing, because if we just discussed the areas when we knew the answers, it'd be a much less valuable meeting. So you've given great answers, great pointers to where new answers may be found, and you've encouraged all of us to explore what your framework and similar frameworks can do so that we can take that technology and apply it in solving very important real world problems. Alex, thank you very much indeed.
Thank you. Cool. Great stuff. Well, yeah, thank you very much, David. Well said. And yeah, I really appreciate your time today. I know it's you know, a big ask, taking a chunk out of your Saturday afternoon midsummer. So, you know, really appreciate it. I saw someone doing a drink sign. I'm not sure if you want to go to the pub or something, but I'll be happy to go for a beer afterwards if anyone wants to have a beer. Basically, just to touch on the final point about the government, basically, there is one initiative that I've been lucky to be involved in over the last couple of months, called the APPG on AI, so the All-Party Parliamentary Group on AI, which basically is helping to take various people from industry, from everyone from startups, large organizations, academia, and basically kind of, you know, over a period of you know, I think it's 18 months or so, there's a program where basically people are providing effectively like evidence, like, you know, kind of select committee hearings where effectively people from industry are advising the government on their perspective on these policies, and that hopefully will then trickle down into, you know, legislators, MPs who, you know, don't have the tech expertise or haven't maybe been as sort of well read on you know, some of the implications from the impact of AI. It can really help them to make you know, more informed decisions about how you know, how they can prepare for these big changes in society. So I'd encourage anyone to like sort of search for that as well. And there's some interesting reports that are coming out of it, and you know, I'm blogging about it now.
So what's the search term?
APPG AI, or the All-Party Parliamentary Group on AI. Yeah.
Great. So,
Okay,
get involved. Thanks,
you.
everybody.
Okay.
And here's the way to the pub. It's a short walk. And
Okay,
we
well,
can discuss
there we
all
go.
kinds of things there, not just the APPG AI, but lots of the other issues about how do we all get to lie on the beach in the future and not just the wealthy who happen to be controlling these AIs. Thanks very
Great.
much.
Thank you.